Hello students. In this video we are going to discuss about heat transfer. As we know that whenever we supply a heat energy to any object, that object start to increase its temperature. That temperature is increasing depending upon the amount of heat we are supplying. How we transfer heat from one body to another body, we are going to discuss in this video all these things. So let's start. Before we start heat transfer, there is a point: boiling and evaporation. Boiling, and next one is your evaporation. Boiling and evaporation. What is the meaning of boiling? The process due to which a liquid changes, the complete liquid changes to gaseous state at a fixed temperature. This process is known as your boiling. Liquid changes to gaseous state at a fixed temperature. This process is known as your boiling, and in case of boiling, the complete part of the liquid start to convert into gaseous form. This is your boiling. And this boiling is also known as your vaporization. It's a vaporization. Always remember, it's a vaporization. This boiling is also equals to vaporization. What is the meaning of evaporation? The process by which a liquid changes to gaseous state at any degree rise of temperature is known as your evaporation. This evaporation depends on the certain changes in climatic condition. It may be change of temperature, it may be change of pressure. During this, the liquid present on the upper surface of the container, upper surface of the water body or liquid body, convert into gaseous part. Only the upper surface, not the entire body. This is known as your evaporation. And it always below the boiling point. Below the boiling point. Below the boiling point. So in your book there is a lot difference between 4-point difference between boiling and evaporation. First I told you that boiling, a liquid changes into gaseous state at constant temperature, but evaporation below the boiling point, not a constant temperature, at any degree rise in temperature. Any degree rise in temperature. Then the process needs an external source of heat energy. In this case, boiling need external source of heat. But this one does not know. Clear? External source not required in evaporation. It is a bulk process. Complete part start to form into gaseous part. This is a limited amount of process. In this case, only the upper surface converts into gaseous part. This does not cause cooling, but this causes cooling of an internal body. So likewise you can differentiate between boiling and evaporation. Now our next point is thermal expansion. First let me rub the board. Whenever we supply heat energy to any body, any solid body, okay, I am using solid body. Solid body start to expand itself. So expansion produced in a body with the effect of heat is known as your thermal expansion. Thermal expansion is of three types. First, it's a linear thermal expansion. Linear thermal expansion. If any body by receiving heat energy only increase or expand itself in a lengthwise, such type of expansion is known as your linear thermal expansion. If any body superficial thermal expansion, if any body expand itself if any body expand itself area wise, suppose if we this is your metal sheet, if we are heating, so this increase itself lengthwise as well as breadthwise, means at the sum of all it increases area wise. Such type of expansion is known as your superficial expansion. Third one is a cubical expansion. Cubical expansion, if any type of expansion expand itself volume wise, such type of expansion is known as your cubical expansion. Such type of expansion is known as your cubical expansion. Hope this thing is clear to you. Now we are going to discuss about ring and ball experiment. Ring and ball experiment. In this experiment, I am simply explaining you. In this experiment, we have a ring fitted with a stand. Clear? We have a ring. This is your ring fitted with a stand and a sphere This is a sphere. Clear? This is a sphere, and internal diameter of this ring is little bit more than the external diameter of the sphere, so that this sphere easily pass the ring. Clear? Easily pass the ring. Now, in the experiment, we heated the sphere. And with the help of some hanging thing, we tried to pass that hot sphere through this ring. We only heat the sphere. What happened? With the help of heat, sphere shows an cubical expansion, increase its volume, and what we observe that this expanded sphere is unable to pass this ray. Clear? Again, we keep some time, leave the sphere as it is for some time so that it can decrease its temperature, compress itself in its original value, and then again try to pass it. What we are observing now, again the sphere easily pass the ring. From this, what we are observing, we observe that whenever we heat a body expand itself depend volume wise or also in area wise equal length, and from this we can easily say that equal length of different solid expanded differently. It depends upon their nature, quality of the material. There are various examples given in your book about this type of expansion. You must read those expansions from your book. Now today, next one we are going to discuss about bimetallic strip and fire alarm. Now bimetallic strips and fire alarm. What a bimetallic strip? In bimetallic strip, we have two different type of strips or pieces of metal of two different metal in equal size, and they are riveted together. So that likewise, suppose it's a part A and this is part B. Both are of different metal and they are riveted together. This is another material. Clear? They are riveted together. A and B. A and B, they are riveted together. So what we can do in this case, A and B, they are different material, and when we supply heat energy to this combined strip, both expanded, but depending upon the quality, one expanded more than the other, anyone expanded more than the other. This type of strip is known as your bimetallic strip, and this strip is used as a fire alarm. Now, if suppose B part expanded more, then after expansion the structure looks like wise, that in that structure A goes inward and B goes outward direction, because B expanded more than the A. They are same. B expanded more than the A. If B expanded more, it covers the A likewise, and if A expanded more, it covers B likewise. Suppose this is A, this is B. And this we use in case of fire alarm. So how we use bimetallic strip in fire alarm? So for this, all of you see this figure. This figure. In this figure, what we are observing that there is an electric bell. Clear? There is an electric bell fitted with some rigid stand. Electric bell. See the figure properly. Now this is a figure of your electric alarm used by biometallic strip. This is your biometallic strip B, and in this case we have one electric bell, and we have some supply of electricity. Here is supply of electricity. Now whenever we switch on the circuit, always we switch on the circuit, but this circuit is break at a point where we have a contact nail and clear, and one side of connection goes. This is your metal rod fitted with the stand. This is your wooden board. This is your biometallic strip, and this is your connection. Clear? Now whenever this biometallic strip receives the heat energy, it shows uneven expansion. Means this not uneven expansion. This expanded less and this expanded more. This part expanded more. This part of biometallic strip expanded more, so that this forms structure likewise. It touches the circuit, that nail and circuit completes and bell start to ring. But this arrangement not properly working, because fire must be reached up to this point and with a large amount, so that this strip B can bend. But electric fire bell concept is absorbed from this part, that biometallic strip bend, complete the circuit, bell start to ring. Now we are going to discuss about thermal expansion of gases. As we know that gases have no fixed shape and size, they have only fixed volume. So gas always shows cubical expansion, and whenever we supply heat energy, gas molecules move away from each other and covers the more area, more volume than the previous one. So gases have no for this we can do an experiment to show an experiment. We place a balloon in above bottle. That bottle is half filled with water, and we try to heat that amount of water present inside the bottle. What happens? Heat converts liquid into gaseous form, gas expanded, and they inflate the balloon. This shows that gas only have the cubical expansion. That's all for this thermal expansion heat transfer. This is a very small one. All of you must read your first unit given in your book. That's all for this video. Thank you.